Ja, welkom allemaal. Welkom bij de webinar van TVVL. Webinar over energieflexibiliteit van gebouwen met behulp van big data. Een onderwerp wat ik al een behoorlijke tijd volg. Ik zal mezelf even kort voorstellen. Ik heb aan de TU Eindhoven Master Building Services gedaan, afgerond in 2016. Toen de tijd al bezig geweest met het onderwerp energieflexibiliteit, middels eigenlijk de data die uit meta-regelsystemen komt. En nu, zo'n 5 jaar verder, als je ziet wat er allemaal op onderzoeksniveau, ik volg het nog steeds een beetje, hoeveel papers er nu eigenlijk over dit onderwerp erbij komen elk jaar. En ook de algoritmes die steeds meer worden ontwikkeld, doorontwikkeld. Dat kan het niet anders dat dit ergens in de komende decennia meer en meer in de praktijk wij dat gaan tegenkomen. Dus zodoende dat ik het ook echt een eer vind om deze webinar te hosten. Shalika, Dennis en Samir die zullen in het Engels vandaag een presentatie gaan geven over het onderzoek dat wordt gedaan aan de TU Eindhoven. Maar voordat het zover is, wil ik jullie nog even laten zien, even meenemen in waar TVVL nou voor staat. In totaal hebben we nu 36 attendees, mensen die live deze webinar meekijken. Maar in totaal hebben meer dan 70 mensen zich ingeschreven. Gelukkig wordt deze webinar ook opgenomen en achteraf gedeeld. Dus dan kunnen de mensen die zich wel hebben ingeschreven dat ook rustig terugkijken. Maar 70 mensen is toch heel wat. Maar er zijn nog veel meer mensen aangesloten bij TVVL. Om en nabij de 1000 persoonlijke leden. En als je eigenlijk ziet aan het aantal bedrijven, dan zijn het er ongeveer 500. Ja, en waar staat TVVL voor? TVVL staat puur voor kennis delen, kennis ontwikkelen, kennisoverdracht en natuurlijk ook het netwerken binnen de branche. Nou ja, wat doet TVVL dan onder andere? Ze hebben expertgroepen en communities. Ik zelf onder andere zit in de expertgroep gebouwautomatisering en beheer. Een van de belangrijkste dingen die TVVL doet zijn cursussen geven. Ik denk dat er veel van ons dat ook wel weten. En mogelijk ook wel eens cursussen hebben afgenomen bij de TVVL, dan wel niet geven. Evenementen en lezingen, zoals deze. Landelijk netwerken. Jong TVVL is iets wat heel erg groeiend is, waar ik zelf ook onderdeel van uitmaak. En ik geloof Dennis ook. En dan hebben we natuurlijk het TVVL Magazine en TVVL Connect. Het online platform wat waar steeds meer gebruik van wordt gemaakt. En waar verschillende kennisgroepen met elkaar kennis ook kunnen delen. Het community platform waar professionals elkaar kunnen vinden en verbinden en aangaan. Online samenwerken, kennis ontwikkelen en kennis delen. Nou, ik heb bijvoorbeeld samen met een goede vriend van mij, Dave Baas, geef ik een cursus. Prestatiemonitoring of HVAC-installaties. Nou, en wat wij dan tegenwoordig hebben gedaan met de cursus, is dat wij nu ook een kennisgroep op het TVVL Connect platform hebben. Waar we dus nu ook actief met oud-cursisten nog na het geven van de cursus kennis proberen te delen. Nou, dat is ook echt precies waar het TVVL Connect platform voor staat. Niet alleen voor de aangesloten cursisten, of niet voor oud-cursisten om kennis te blijven delen, maar ook bijvoorbeeld na aanvang van deze webinar om nog met elkaar in contact te blijven over dit onderwerp. Dus mocht je hier nog niet bekend mee zijn, TVVL Connect, typ het in Google, tvvlconnect.nl, ben je er ook direct en bekijk het eens en wellicht kan het wat voor jou betekenen. Nou, het programma voor vandaag, de opening, daar zitten we nu, dat ben ik nu aan het doen voor jullie. Maar we zitten hier natuurlijk uiteindelijk voor de presentaties. En als eerst gaan Samir een korte presentatie geven. En introductie en case study door Dennis, die volgt, samen met Shalika. Hier staat dan uiteindelijk wat ik nog wel even wil toelichten. Vragen, die mag je stellen via de chat, continu, tijdens de presentatie. En ik zal gaandeweg de presentatie, vragen aan Shalika, Dennis of Samir stellen. Je mag die vragen mag je in het Engels typen, maar je mag ze ook in het Nederlands typen, wat jou het beste uitkomt. Weet wel dat, hoe dan ook, ik zal de vraag in het Engels stellen en het antwoord zal waarschijnlijk ook in het Engels terugkomen. Dus hou er even rekening mee. Dan wil ik nog even, voordat we verder gaan, met jullie delen dat de volgende TVVL-bijeenkomsten op de agenda staan. 9 november is een einde daglezing, best wel interessant onderwerp als je mij vraagt. Urban mining. Circulair bouwen is denk ik iets wat steeds belangrijker wordt. Verder hebben we een tweetal webinars op het programma staan. 4 november webinar voor Connect 2030 en 10 november een Q&A sessie over circulaire installaties. En verder zijn er nog een aantal landelijke bijeenkomsten gepland. 2 tot 4 november bezoek aan onze stands tijdens Building Holland. 24 november TVVL Techniekdag 2021. Be there, ik ben er zeker bij. 24 november Jong TVVL Ledenlunch. Dat is helaas niet voor iedereen weggelegd. Daar moet je onder de 40 jaar zijn, dames en heren. Dus ben je onder de 40 jaar, ik ben er ook bij. Meld je aan, Jong TVVL. 2 december Jong TVVL Eindejaarsfeest, ook mooi. En 30 juni Jong TVVL Zomerfestival. En dan wil ik nu vragen aan Dennis en Shalika of Samir om het scherm over te nemen, zodat jullie kunnen beginnen met jullie presentatie. So, Shalika and Samir and Dennis, switching to English. You can now start with your presentation, guys.
Thank you. Thank you for giving me the opportunity to talk about my project. The name of the project is the Transact, and it was funded from the Dutch Design Council. And the consortium consists of universities, professional learning providers, and companies involved in the building installation and services sector. The title of my project is the learning and knowledge sharing of data analytics and machine learning applications in the building services sector. So to understand what is the skill level of the existing workforce who are working with the building data, which is now increasing a lot with the development of technologies and automation. So we plan to conduct several webinars. This is the finding from one of the webinar we conducted in the company Kropman Installation Technique. And the employees found that the live webinar and short videos are one of the preferred media for learning. And text file is least preferred for learning media, which is kind of academic. And you have already seen a pre-webinar questionnaire that we have circulated along the news for today's webinar. So we have found a different perspective from the professionals that the top preference is the live webinar and the least preference is the classroom type of learning that is physically appeared to any classes. And again, the level of skills on today's topic, we found the mean value is above 3 in the scale of 5. And we want to understand more of the skill set of the existing workforce to plan our upskilling and reskilling to meet the upcoming demand for data analytics and implementing new machine learning applications with new techniques. So now I would like to request all the participants to have a look in the chat section where I have shared a link where you will see an assessment rubric that you can fill in, and that will help us to continue further the research. So I would like to give the time to the participants to check the link, fill in the form, and then we can continue from 11:15, our next presentation from Dennis and Shalika.
Thank you, Samir.
Well, we have more than 20 responses already.
Oh, wow.
Thank you, everyone. So I would like to hand over to Dennis and Shalika from now.
Thank you, Samir. I think your study also highlights the importance of sharing knowledge. And while we spearhead the research from the Eindhoven University, I think it's also key to work together, to share the knowledge and to find out the best ways to do so by using surveys like this. Because in order to take steps as industry towards getting flexibility into the field, we need to start cooperating and also develop our skills as an industry in order to really participate in the energy infrastructure. So thank you again, and for those who have not yet filled in the questions, please do so. You can also do it after the presentation. I think your input will be very valuable, not only to the research of Samir, but to industry in general. So, but let's start with the main course of today, so to say. So my name is Dennis van Gogh, and I will be presenting together with Shalika. And also, while we are having this presentation, there is time to put in your questions. We also have some moments to stop and see what you're asking, because energy flexibility of buildings and using big data in order to get more flexibility from buildings, it's a huge topic. It's a very big topic. Today, we will go in depth a little bit on some of the key aspects. But we will not have time to go in depth on all the different aspects that are related to this topic. So be sure to post your questions as well. Now again, my name is Dennis van Gogh. I'm working at BAM as a program manager innovation. I've been working on smart buildings and smart communities for the entirety of my career. And we work a lot in cooperation with the Eindhoven University on research programs and research topics. So I will give you a broad introduction, and Shalika will go ahead and give a deep analysis using the case study that she did. And then at the end, I will come back to you and talk about the next steps that we are planning. So let's see if this works with the slides. It does. Okay. A small starting point, the state of affairs in the Netherlands. And you cannot miss it, it's all over the news constantly, but the state of affairs is that we are consuming a lot of energy, pretty much 2,500 petajoules of it. And a major chunk of that is being used in the built environment, in the buildings that we use for living, for working, and also for production. So in order to make our transition, in order to meet our climate goals, we need feasible alternatives for discontinuing the use of gas. And it's evident from the news today that it has not been more pressing, I guess, than today. So one of the things that we are looking at is electrifying a huge part of this demand. Instead of using natural gas, we can use electricity. And if the electricity is being produced from renewable sources, then we can also reduce our CO2 footprint, and we'll be moving ahead. And in order to do that, we need to think of buildings in a different way. They're not just boxes that we put into the field. And then after we put them in the field, we say, okay, good luck with that. Don't call us if you need anything. No, we need to stay engaged with the customer, stay engaged with the client, and actually measure what's going on in the buildings themselves. And let that be a starting point of today, because we already know that we can save a lot of energy. And this is obviously the first step that you should take. If you follow the trias energetic concept, for instance, it comes down to design your building in a nice way, insulate, and reduce your consumption. And we are quite aware of how to do so. It's not all implemented in the field, and there are huge challenges in getting the whole set of buildings that's in the field and make sure that they reduce their consumption. But for the renovation projects, for instance, that we run, we know more or less that we can save up to 60% of the primary energy requirements in that building. And we have more than enough examples to show that we can really improve the buildings there. But we've also learned from the past couple of years that that's not the end station. As I just said, you should stay involved, and the actual performance in the building, that's something that's measured in the field. And you need a data connection to your building. You need sensors, you need to measure what's going on. You need to give feedback to the end user. So the last 10 years, we spent a decent amount of time to developing these systems and get them into the field. And I've I'm showing you quite a complex figure of that. So you can use it as a treasure map, basically. So we start off with the end user, make sure that we have the monitoring installations in place, make sure that we have a safe data connection to the building, and then use that data in order to do our smart things. And that led up in the past couple of years that we've started building quite a large platform where we get where we engage with all our buildings. So for BAM, for instance, in our data management department, we have a lot of buildings connected to it. So over 2,500 buildings are being monitored via the building analytics platforms that we run. And just to give you a taste of how this accumulates in terms of data, that's over 180 samples each second that we obtain from the field. So this is 50% utility buildings, 50% residential buildings. So there's already quite a lot going. And we use that data, obviously, for reporting. We use it to improve our performance of our buildings. We use it to improve maintenance, to be able to detect if something is going wrong. And importantly, we also use it for user feedback. So we can more or less conclude that the problem is solved, right? So we save a large part of the energy. We are in touch with our customer base. We are in touch with the people, and we can prove that we have an impact. Well, wrong. So if you open a news site right now, I'm pretty sure that in the top news of today, there will be at least one bullet who is talking about how congested our energy system is at this moment, how expensive energy is at this moment. So for one reason or another, we did not solve all the issues that we have. So we know that adding a lot of renewables to the energy infrastructure, it leads to congested infrastructure. And it will cost us as BV Netherlands, a lot of money in order to make sure that we don't have traffic jams on the energy infrastructure. But at the same time, we cannot add more renewables. At the same time, our energy prices are going up. So we need to find a solution for that. And this is not something that's happening in the future. That's something that you can see from the news, but we can also measure it. So we now have an understanding of where the networks are congested. And we also know that if we put a building in the field and we save a lot of energy, but we also add a lot of renewables on the building premises itself, that also the buildings have an impact. So it's not only the renewables that we're adding that feed in energy, it are also the buildings that are consuming energy in a different way. So here we see, for instance, a slide with on the left side a graph, and the blue line is showing a normal consumption pattern. So this is like a regular house. Now the red line is showing a renovated house where we added a lot of PV. And we can see that there's a huge feed-in peak. So this is the negative peak, which means that instead of just regularly consuming, and this is where we designed the grid for, at certain moments this house is going to give a lot of input. And now we have to basically imagine that this is not just one house, but these are 200, 300, 400 houses who are all doing this in the same time. So the problem we solve by saving energy and by adding renewables also leads to new challenges. And these new challenges are something that we have to solve, else the buildings that we make and the renovations that we do become part of the whole problem. Well, we think that if you are smart and capable of controlling your energy flows, that the buildings can actually be a part of the solution. And that's basically the next step in sustainability. That is, do not only look at your own building, do not only use the data to improve your energy performance and your comfort, but also think of how your building can solve the problems for the infrastructure. Are there moments where we can reduce our consumption? For instance, to avoid peaks on the network. Are there moments where we can use locally produced energy in another building such that we can make sure that there's still a balance between feed-in and consumption on the network? So the next step in sustainability is looking outside of your front door and cooperating with the environment, with your community. And that requires us to not only use data in retrospective way to report, but also use your data to look ahead and see how you can adjust. So that leads to the first to the case study that we want to introduce, and then I give the word to Shelika with one of the key questions: how can we use big data to enable flexible buildings and flexible communities? And with that, Shelika, I'd like to give the word and the floor to you.
Yeah, thank you very much, Dennis. So I will, yeah, thank you. So first of all, let's see, when talking about electrifying heating sector, why exactly we need flexibility and data collection of the or data analysis of these buildings. As you can see here, now I have shown you a study that we have done with different scenarios for an individual house, individual building, in an individual commercial building, and in an house, to see whether going all electric is the right way at this moment for this energy mix in the Netherlands. So here we try to analyze scenarios with individual boilers, a hybrid scenario where a boiler and a heat pump work in parallel, and also an all electric case where a heat pump is the only case for the heating to provide the heating demand. And from here we saw, okay, I cannot, okay. So here we saw the study actually discovered the hybrid scenarios are in favor at the moment for the current energy mix in the Netherlands. So that means we have a problem going all electric, and introducing heat pump does not actually solve the problem, as Dennis says. So what is the solution? What can we do about it? So one solution is to increase energy self-sufficiency of buildings and building neighborhoods. But the problem is the intermittent behavior of the PV panels or the renewable energy sources, renewable energy production. So one major player is the battery storage systems to introduce flexibility to the grid, to the buildings. So we want to introduce battery storage systems and also optimally control these battery storage systems in order to match the PV production and the building energy consumption. There comes the data analysis and the demand predictions. Let's see how can we utilize this battery energy storage optimally with the help of data-driven demand prediction methods. So here the objective is to mainly to increase energy self-sufficiency so that we can reduce the negative peaks or feedback electricity to the grid, and also give some flexibility to the grid side. So I have highlighted data-driven demand prediction because prediction is the functionality that comes mostly with flexibility. So here, when we talk about demand prediction, it can be done in different levels. It can be done in building subsystem level, building level, neighborhood level, according to the user and the stakeholder requirements. So first, I will show you a study that we have done with the demand prediction of subsystem levels. So when I say subsystems, the buildings have HUs, chillers, lighting, plug loads, PV panels. So all these systems are connected to the building and they are subsystems. And the summation of the energy consumptions of all these systems represent the total energy consumption of the building. Therefore, what we did is first try to collect data of each of these systems separately and see whether we can predict each of these systems separately. But here, when we talk about demand prediction, you can use several methods also. One possibility is using mathematical representations of these energy systems. So I will show you an example for the HU. Now, I'm not going to go into details of this graph, but this graph shows the energy consumption of the AHU with the changes of the outdoor temperature. So now you can see if I can fit a mathematical model, or if I can fit a graph along this data set, and then I can know when the temperature changes what will be the energy consumption of the air handling unit. So this is an example that we have done. So we have tried to fit a curve along this data set. Then, as you can see, this is the equation that represents that curve. So when we know so from this curve, with the outdoor temperature, we can have a prediction about the energy consumption of the air handling unit. So this is something that you can do subsystem for intra-building level load groups. So likewise, this can be done for each of the load groups by using different mathematical representations for each of these load groups. And then what we try to do is, by taking the predictions, day ahead predictions from all these data, from all these demand categories, we try to give some flexibility to the demands, to the grid side, by playing with the demand curve. So as you can see here, we try to make the demand curve flat by shaving the peaks and filling the valleys. So how did we make the demand curve flat? By using a baseline estimation, as you see here. So what we have done is, using the day ahead predictions, we made an algorithm to see what is the optimal point or the optimal baseline that we can draw, so that the peaks and the valleys can be shaved and the valleys can be filled as much as possible. So this is one way of giving flexibility to the grid side from the building. Actually, this was a successful study. We implemented in Kropman Breda building, a living lab. So we managed to maintain a flattened demand profile over 95% of the time that we have tested. And most importantly, there were no complaints from the building users. But we saw the energy consumption, electricity consumption has increased a little bit because of the on and off of the battery storage system. However, there's a major problem with this method, with this type of demand prediction. This is a labor intensive process. It takes a lot of time to build up these mathematical models. So we need to see, okay, what other demand predictions methods are available in the market, or available in the world. So there we go for machine learning algorithms. So this is an advanced data-driven algorithm where we use, instead of mathematical representations of the model. However, when using machine learning algorithms, we need to follow a certain process. I will briefly explain what is this process. First of all, we need to take the raw data. And when we collect the raw data, there can be so much outliers. There can be missing data points according to our sensor performances, and also noise data sets. So we need to remove all these data, and make the data set valid in a way that we can make a prediction model. So that part is called the pre-processing of raw data. And after pre-processing, we get a data set that is possible, that is usable in a way to make a prediction model. So the next step is feature selection. So feature is an input that we can use in a way to predict our output. For example, now I want to predict the heating demand of a building. And I know the heating demand of the building is changing according to the outdoor temperature. So I don't have a specific mathematical equation that represents the temperature and the heating demand. that connects that connects the heating demand and the temperature, but I know that this has an effect. So temperature is a feature that I can use to predict the heating demand. So likewise, we have to select, we have to choose what will, what are the other features that we can use to predict the output that we want. After selecting the features, then we go to the model development. So this model development can be done using different machine learning algorithms. And then we need to validate and train the model, validate and calculate the errors. The error calculation means now I predict the demand and I have the actual demand also. I see what is the difference between these two. This shows the error. So I will show you one error matrix that is important. Okay, I cannot. I cannot go to. Okay, so this is one error matrix that is important, and I will that is important to share. This is given by ASHRAE standards also. This is called the coefficient of variance of the root mean square error. So in the ASHRAE standard, it says if this error is less than 30%, it is good enough for engineering applications. So therefore, I will only talk about this error matrix in this presentation. But it's not when we make a model, we need to compare different error matrices, not just one matrix. So let's go to the next step. Now, in this case, I'm going to talk about individual building level demand prediction, because in the past case study that I showed in the presentation, we saw that even though we looked into subsystem groups, at the end, what matters is the total energy demand of the building for this case study. So therefore, in this one also, I'm going to talk about the total energy demand of individual buildings. So here, this is a case study that we have done for a campus neighborhood. Yeah. So in this case study, I'm going to talk about the prediction of individual buildings. So here, what we have done is take the electricity consumption of building by building, the total electricity consumption, and try to make prediction models using machine learning algorithms. So here I have used 3 machine learning algorithms: boosted tree, random forest, and ANN. And I only show here the CV root mean square error. But there are several other error matrices also, as I mentioned before. And as you can see, the 30% or 0.3 is the desired margin, and anything less than that is considered as a good prediction. But however, we see when I have showed here 8 buildings, the last building is not performing well according to what we want, according to the error matrix. So why is this? What happened here? So the problem occurred here is when the collected data, we saw because when we make a model, the model should identify a pattern. So if it identified a pattern only, it can predict according to that pattern. But however, we saw here the functionality of the building changed in between. So the collected data was not enough to provide or to predict, to make a good prediction. So this is a problem that we encountered when we consider the individual buildings as one unit. But however, in the future, maybe in the aggregator perspective, maybe taking individual buildings is also not be the way to go. Maybe we should go to neighborhood level. So let's see in the next slide a study that we have done with the whole neighborhood. The same case study, without taking individual buildings, we moved into the whole neighborhood and tried to predict the whole neighborhood energy consumption. Here we see in this graph, I have shown a few number of hours, the actual demand, actual consumption, and the prediction. So the blue color line is the actual consumption, and the orange color one is the prediction. You see here, it's very smooth. The graph is smooth, and also it follows the actual consumption pretty nicely, pretty accurately. But the problem here is now we actually lost all the information about individual buildings, because when it comes to the neighborhood, the energy consumption is averaged. So we kind of lost the information about individual buildings. The prediction is actually very accurate. We can go to a very good prediction, demand prediction model. However, the information lost is a problem. Then what can we do about this? How can we deal this problem? So one solution to deal this problem is to cluster the demand patterns, cluster the buildings that performs in a similar pattern, similar way. So the demand prediction can also be improved while preserving the characteristics, while maintaining the information of the building groups. So this kind of reduces the complexity of predicting just one building, but this also makes a solution for the information loss. So with this learnings, with these findings, we exercised these learnings in another case study, which is a renovated small neighborhood with heat pumps and PVs. This is a case study with 70 houses, and we introduced a neighborhood level battery storage system to this case study. And without introducing the battery storage system or any data analysis on this neighborhood, we found the existing self-sufficiency is around 10%. However, this neighborhood is, when it comes to the annual case, it is energy neutral annually. But if we go in detail to self-sufficiency, it is around 10%. So after introducing these flexibility measures, we could improve this neighborhood to become 100% self-sufficient in 4 months of the whole year, and the total self-sufficiency could be increased up to 40%. Now, in this case, we see after introducing these measures, flexibility measures and data analysis measures, these all-electric solutions can be in favor in the future. So there are some take-home thoughts that I should like to share with you. So I showed some case studies in the sub-component level, sub-building component level, individual building level, and neighborhood level. So the level of detail required is up to the consumer, is up to the stakeholder, because you need to decide which level is enough, if the whole building prediction is enough, why do you go to a sub-component levels? So you need to decide which level is enough for my problem, and what is the purpose of collecting this data, because collecting data is money. When we accumulate a lot of data, we need sensors, and this data should be reliable. So we need storage systems, and when the data collection is when it's too much, then you need high-speed computers, and then at the end, then you will need to upgrade computer architecture. So it comes with money. So what is needed is the clever use of this data. Now, if we have energy consumption data with one sensor, how can I use this information to make a prediction? And is it really necessary to collect a lot of information or a lot of data? So this part, the stakeholders and the data users have to decide, because collecting data is not what we want. Using the data collected in a useful manner or a clever manner is what we want. So this ends my case study. So Dennis, you can take over.
Yeah, thank you, Shalika. So let me show a little bit how we actually use it, and then we can judge if we use it in a clever way, because you're absolutely right. Obtaining more data, or let's put it in a different way. With big data comes big responsibility. Let's put it like that. So let's take a look at the value part and how we actually use it in the field. Not only the data, but also the principles that Shalika explained. So one of the things that we do is that we actually build smart communities, because for us it's part of the answering the key challenges about congestion. We have to work together. So we are constructing smart residential areas where we not only save energy and not only use efficient installations, but we also actively control all the installations as to optimize the local energy consumption. And that's where we start using these algorithms, because we need to look ahead. We need to look ahead at what time am I going to use energy from an individual building point of view, such that we can optimize the exact moments when you're going to do that. But even beyond that, we need to orchestrate the energy flows in the neighborhood as to avoid moments in which everybody is going to take a shower at the same time, or avoid everybody feeding back into the grid at the same time. And for that, we did some trials in 240 houses, 3 neighborhoods in the Renovate project, which is also one of the locations that Shalika just showed, which was used as a case study. And then we saw that we while implementing this, we can save up to 10% on energy consumption on the building level. We can increase the amount of energy self-sufficiency by 30% on individual house level. And from a neighborhood perspective, when we combine it with a neighborhood battery, we can save up to 90% of the congestions that we are facing. So this is one of the examples how we use it. And by the way, I'm aware of the time. I have a lot more to say to you, but the time is limited, so I'm aware of that. And one of how would it look like if you're in a community? You can start sharing energy. You can work together, and this working together part is quite important. Here we just show a dashboard example of a trial that we run in Woerden. But let's get to the next sheet, because Shalika told us something about that obtaining data is not for free. You need to think of your sensors, and I also touched upon this topic at the beginning. So let's take a look at the value. What can we actually get from using this flexibility? So I already mentioned 5 to 10% of energy savings, and this depends a lot on how much flexibility that you can actually obtain. So, and that depends a lot on the buffers that you are using, on the subsystems that Shalika introduced. So just to give you an impression, if you have a heating storage vessel in a regular house, you can expect about 1 kilowatt, 1.5 kilowatt, and 1.5 kilowatt hours of buffering capacity that you have there. And this is increased dramatically if you start thinking of using batteries. And also in the utility scale buildings, of course, that's becoming bigger even. So we usually, as a rule of thumb, we estimate that we can get 100 kilowatts or 100 kilowatt hours of flexibility for every 10,000 square meters of buildings. And if we use that for reducing your peaks, for instance, the 100 kilowatt, we expect a value of about 24 euros per kilowatt. If we use it in order to buy energy at the cheapest moments, then we expect somewhere in the line of 50 to 100 euros per megawatt hour. If we reduce it on a if we use it on a community level, we can reduce the congestion, and the value of that is really depending on the location where you are in the Netherlands. Is there a congestion problem, or is there not a congestion problem? But if we use the same flexibility in order to participate in the balance markets that we run in the Netherlands, so these are run by Tenet, for instance, then you can expect a value of about 100 euro per kilowatt of capacity. And this is actually the situation right now. You can stack multiple cases. So you can use your flexibility for one thing or the other. And it's always a balance, and it requires a lot of, let's say, algorithm deployment and optimization in order to pick the best strategy for that. But it is important to stress that this is the value that we have in 2021. And we do expect that markets will become more volatile. We do expect more renewables being added. So in general, we do expect that this value is going to increase as well. So then the next question arises, how can I obtain this value? How can I participate? And what we do there is that we connect buildings to markets where we can use the flexibility. One of the markets that we have today are run by TenneT, for instance, AFRR or FCR, where you can use flexible energy to balance the entire system. And this is an auction. You can connect to it. New initiatives are, for instance, GoPax, where you can contribute to the reduction in congestion in your neighborhoods. And another way to use your flexibility is implement local energy communities and enable people to share the energy. But then you touch upon a set of different values, so not only for balancing. And we try to use the layered energy system, which is put forward by Stedin as a more or less open source and standardized solution in order to run communities. And that's something that we do in the Renovates program. And with that, I wanted to stress, and maybe this is my final slide also in line with the time, is that if you want to go ahead, we need to work together. Because you need to connect your buildings, obviously, to a market. You need to obtain data. You need to do clever data analytics in order to, understand what the best use is for your flexibility. And you need to connect to other parties in order to obtain the value. So work together. Share your data. Don't keep it all to yourselves, else nobody will know when there's a problem on the network, or nobody will know what you, with your building, are capable of doing. And focus on more than just energy, because we learn from clients that it's about energy, it's about cost, but it's also about, for instance, CO2 footprint, getting a track and trace of where the actually energy is coming from at each moment, but also working together in communities itself. Cohesion that you get from that is an important part, not only for residential clients, but also in the utility sector. And with Truth, I'll just skip this slide. With Truth, we are building a program which forms the next step in getting these energy communities together, where we connect, first and foremost, we connect individual buildings into these communities. And with the communities, we can support the energy network and the energy transition. And the solution that we envision there is right at the middle, such that we can use the value that we obtain from supporting the energy network and use it to further accelerate sustainability and demand reduction actions at the building level itself. So you can look at the screen afterwards. I'm pretty sure that the slide deck will be shared. But with that, I think it's good to end my story such that we also have some time to answer questions. So Werner, I think that's back to you.
Ja, dankjewel Dennis. Thanks Shalika. En also thanks Samir, of course. Ja, ik zal hem even in het Nederlands afsluiten. Maar voordat we afsluiten wil ik eerst nog even aan jullie de vraag stellen. Zijn er überhaupt nog vragen? In de Q&A zijn er een tweetal vragen gesteld. Die zijn volgens mij beantwoord. Zijn er mensen die nog een vraag willen stellen? Dan wel in de Q&A, dan wel dat ze even hunzelf unmuten en hem stellen.
Ik zie één vraag, als ik het goed heb. So permanent connection to the internet is key. And I can answer that. So a connection with the internet for a building is indeed key. If you want to remotely operate, but also work together, so for the exchange of information. Then the second question, is it necessarily permanent? I don't think so. There are two things. Each building should be able to operate without an internet connection. So it's not a replacement for any local control systems. So you need this independence still. And then also locally, you can already do a lot. And even further, we try to ensure that as much as the optimization is done locally, because this also limits the information that needs to be shared. Also from a security and privacy perspective, that's important. But if your internet connection drops away, then the building, of course, should be able to operate for itself. And then secondly, should it always be connected to the internet? There are possibilities to close your connection if not needed, and that you receive a call or a handshake at the times that you do need to open up a channel. Hopefully by that I answer this question.
Dan denk ik dat we er bijna wel zijn. When do you want to implement to gather data? Vraagt Rogier.
Het is een beetje een lastige vraag.
Data. Yeah, it's
so in Dutch, when you want to
It's kind of an abstract question. You can interpret it in different ways. Do you want to start up a research? Do you want to start up?
Yeah, of course, gathering data should be a part of your development phase and the initial concept. So you need to take care of how you're going to gather data right there. And when we want to do it, it's right now. We are already doing it. Rogier is giving some feedback. Did we interpret that? Which data do you want to save and measure? Yeah, that's case specific. So for every project that we run, you are going to basically ask yourself, okay, what are the use cases for which we are going to use the data? What do we need to guarantee? And that translates to what we need to measure. So we only want to measure what we actually need, like Shalika also mentioned. There are some guidelines for that. So international IPMVP, which is more or less a guideline on to see, okay, what do we need to measure if we want to ensure performance on one aspect or the other. Sorry for the separate lines. Yeah, okay. But hopefully I more or less, because we try to interpret your question, Rogier, and hopefully we pick the right direction.
Ja. Ik wil daar nog wel even op door. Ik ga hem even afsluiten, Dennis. Maar ook voor Rogier en ook voor de anderen. Zojuist heb ik een tweetal berichtjes nog even in de algemene chat gestuurd. Het eerste berichtje is over de survey van Samir voor zijn onderzoek. Nu zijn er wel aardig wat mensen weer weg, maar er zitten er nog 30 attendees in. Hij heeft in totaal 23 mensen hebben zijn survey ingevuld. Dus graag nog even de herinnering van, mocht je dat nog niet gedaan hebben, het wordt erg op prijs gesteld als dat wel wordt gedaan. Want die data die hebben we nodig, of die heeft Samir met name nodig, om zijn onderzoek zo goed mogelijk te doen. Daarnaast heb ik ook nog een linkje gedeeld over een cursus van de TVVL omtrent data-analyse op HVAC-installaties. Dit is een cursus die ik zelf geef, samen met Dave Baas. Het gaat er niet zozeer op in hoe je algoritmes maakt voor demand-side management. Want het is een 4-daagse cursus en dat is wellicht iets te geavanceerd. Maar het gaat wel in op het gebruiken van de programmeertaal Python. En we gaan met een groot aantal verschillende datasets van HVAC-installaties gaan we aan de slag. Om met name ook hands-on ervaring op te doen omtrent het eruit halen van inefficiënt gedrag. Van verschillende installatiecomponenten, maar ook als een systeem als geheel. Ik zie hier een vraag. Is the training going to be available only in Dutch or also in English? In principe is het Nederlands. It's Dutch. All the slides and all the assignments are everything in Dutch. However, we maybe can make, we can maybe switch it a bit to English if really necessary. But in the basis, it's in Dutch. Dus ja, ik wil jullie vragen, vul de survey in. Wanneer je die nog niet hebt ingevuld, dat wordt erg op prijs gesteld. En mocht je meer informatie willen over de training die TVVL ook geeft omtrent HVAC, data-analyse op HVAC-installaties, klik op de link, bekijk de beschrijvingen en je mag mij eventueel ook direct contacten via LinkedIn bijvoorbeeld. Dan kunnen we altijd vragen beantwoorden. Dan wil ik jullie bedanken voor jullie aanwezigheid. Dennis, Shalika en Samir, thanks for the presentation. It was really informative, and I find it a very interesting subject, so I'm always hooked to this kind of presentations. But yeah, nice job.
Thank you very much.
Thank you.
Oké. Fijne dag allemaal.